A warm welcome for everyone to the CUET sessions. Well, CUET, it's pretty much a vast area of topics we have in that CUET exam, as you are aware. However, we'll just simplify it. Probably would take a look at, what logical reasoning. Otherwise, it's known as mental ability area. This is one of the most interesting, at the same time, bit challenging as well. So let's go with this, series type of questions. Series especially will take a look at number series first. So otherwise, it's known as patterns as well. Number series or number patterns. Let's go with some of the examples. 22, 29, 36, 43, and what's the next number in the series? So we need to find out what exact the pattern behind these numbers here. So 22 and 29. At a glance, we can see that 7 is the difference here. And 29 and 36, same difference, 7. So 29, 36, 7 is the difference. And 36 and 43, we have the 7 difference. So it's equal difference. 7, 7, 7. So next difference must be 7 as well. So 43 plus 7, 50 is the answer. This is one of the simple example of a number series question. You know what? You may not get that kind of so simple questions in the actual test. So this is for you to get an idea what exactly is number series. Next one, 17, 19, 22, 26, 31. So what is it? 17 plus 2 is 19. 19 plus 3 is 22. And 22 plus 4 is 26. And 26 plus 5. So when we look at the difference, 2, 3, 4, and 5, of course, these differences are natural numbers, 2, 3, 4, 5. So next difference would be what? 6. 31 plus 6 is what? 37. So the answer for that question is what? 37. Next one, 9, 11, 14, 19, 26. So we'll try that one. So 9, 11. So 9 plus 2 is 11. 11 plus 3 is 14. 14 plus 5 is 19. Okay, so that's something interesting. Plus 2, plus 3, next one is plus 5. And what is the next difference? It's plus 7. That means 19 plus 7. So 7 is the difference there. So these are not really consecutive numbers here. 2, 3, if it is 4 and 5, perfectly all right. But what we have is 2, 3, then it is 5, then it's 7. So what is the next difference? What would be that? Is it like 26 plus 9, 35? Is that the answer? I'm pretty sure at least some of you thought about that answer, 35, right? But in this case, look at the differences, 2, 3, 5, and 7. What are they? Is there any peculiarity for those numbers, 2, 3, 5, 7? Look at those numbers, 2, 3, 5, 7. These are the differences. So these are what? They are known as prime numbers, right? So next prime number is what? 11. And the prime number after that is 13. It goes like that. So we have the next number or next difference right here is 11. So 26 plus 11, that would be the answer. How much would be that? 26 plus 11, 37. So if you look at these two series, then you can see the difference here. This is 2, 3, 4, 5, 6 difference. And this one difference is 2, 3, 5, 7, and 11, that difference. So these differences are what? Prime numbers. All right, so what is the next question? 26, 37. So we have another series here. 26 and 37. The difference is what? 11. And 37 and 50. 13 is the difference. 50 and 65. 15 is the difference. So what are these numbers? 11, 13, 15. Are they prime numbers? Well, 15 is not a prime number. So 11, 13, 15, these are consecutive odd numbers. So, well, 11, 13, 15. Next odd number is what? 17. So 65 plus 17, how much is that? 65 plus 17, that would be the answer we are looking for. 65 plus 10, 75 plus 7, 80. How much? 82. So 82 is the answer here. For this question, we have what? 2-digit numbers. This method is perfectly all right. or we can manage with that method. But you know what, some of the questions which are like 3-digit numbers, finding difference would be a little bit time consuming. So in that case, do we have any other method to deal with this question? Any other method? For example, for this last number series here, 360, 399, 440, 483, and if I give you one more number, 528, then what is the answer for this series? So when you take a look at this, you know what, 483 and 528, finding that difference using mental calculation would be a little bit time consuming. For that, what is the best method? So this question, what I want you to do is connect it with some other numbers. We'll try to do the similar thing right here for this question as well. I'll just write down those numbers here. 2637, well, 26, 37, 50, and 65. Is there any other peculiarity for the numbers, for these numbers, other than what we have seen, 11, 13, 15, 17, that difference? Other than that, is there any other peculiarity for these numbers? Let's take a look at that. 26, 37, etc. When I look at those numbers, what I see when I look at 37, visualize that 36. Automatically, that 36 comes to my mind. How about like 26? When I look at 26, I think about 25. And when I look at 50, what comes to my mind is what? 49. It's pretty much, you know what, if you're familiar with the numbers, all these numbers come to your mind automatically. And 65, when I look at 65, what comes to my mind is 64. And is there any peculiarity for these numbers? 25, 36, 49, and 64. These are squares of natural numbers, right? That means 5 square, 6 square, 7 square, 64 is 8 square. So that means this, what 26 is what? 5 square plus 1. So it is what? 25 plus 1, 5 square plus 1. How about 37? It's 6 square plus 1. How about like 50? 50 is what? 7 square plus 1. And 65 is 8 square plus 1. And the answer, what we are looking for is 9 square plus 1. 9 square, 81. 81 plus 1, 82. That's the exact same answer we have here. See that? There is another way of looking at this question from the angle of squares. So using the square pattern, we can get the answer. Of course, if you take the difference, you can get the answer as well. And now look at this question. 399, 360, 440. When you look at those numbers, do you see anything here? I like this number, 399, because it's pretty close to what? 400. What's a peculiarity of 400? 400 is what? 20 square. So ultimately it is 20 square minus 1. It's 20 square minus 1. And how about 440? Is that like 21 square minus 1? What is 21 square? 441. 21 square is 441. If you are familiar with the squares of numbers, squares and sometimes cubes of numbers, that would be easy for you to deal with these questions. By the way, this is 21 square minus 1. How about this one? This is 21, this is 20. How about this one? 360. Is there any square near to that number? 360 may not be a perfect square, but is there any square near to that number? Well, it is 19 square. 19 square is 361. So this is 19 square minus 1. About 483. Definitely, if these three numbers fall into this category, most probably, fourth number would fall into the same pattern. What is it? 22 square. 22 square, 484. So 22 square minus 1 is 483. How about 528? 528 is what? 23 square. 23 square minus 1. Well, the answer what we are looking for is 24 square minus 1. How much is 24? 24 square? It's 576. So the answer is 575. See that? The squares of numbers will give you pretty good an upper hand on some of these number series. Not all the number series, some of this. At the same time, I'm pretty sure at least some of you have tried the differences here, right? So look at the difference, 360 and 399, that difference is 39. About 399 and 440, the difference is 41. And 440 and 483, the difference is what, 43. And next difference, well, 483 and 528. 483 up to 500, that difference is 17. Then we have a 28 here, 28 plus 17. This is a rounding method, 28 plus 17. Rather than adding 28 directly with 17, what I do, 28, I'll just make it 30. From that 17, I borrow 2. It's mental calculation, rounding method. So 28, we need to add 28 and 17. I'll just write those numbers here for you to get an idea, 28 and 17, but we are not really going to add in a conventional way. So I'll take that 2 from here, 28 plus 2, 30. So when that 2 is taken from 17, balance is 15. So that 30 plus 15, 30 plus 15, 45. So next difference is what here, 45. Now look at these differences, 39, 41, 43 and 45. What are these? Consecutive odd numbers, 39, 41, 43, 45. Next difference must be 47. So 528 plus 47, you get the exact same answer. 528 plus 7, 535. 535 plus 40, 575. Well, you know what? Finding out that difference is a bit time consuming rather than when you compare with the previous question. This question, finding out the difference, it was really easy. So if you get a question like this, you can go for either method, either find the differences or go for square method like 5 square plus 1, 6 square plus 1, etc. But when you get a question like this, 3-digit numbers, don't go for finding the differences because it's time consuming. So what I suggest is go for what, square method. And if you are pretty good with the squares of numbers, definitely it is good. I'm pretty sure everybody knows the squares of numbers from 1 to 10. It's easy, right? How about like 11 and 12? Many of you know the squares of 11 and 12, I'm pretty sure. So 11 is what? 11 square, 121, and 12 square is what? 144. Now, 13, 14, and 15, I'm pretty sure everybody knows the square of 15 as well. So 15 square is what? 225. Now, what is missing in between? 13 square and 14 square. So 13 square is 169 and 14 square, how much? 196. So, if you know these 1 or 2 squares in between, if you are not sure about it, if you just look at what the 13 square and 14 square, then you have reached up to the squares of 15 by this time, correct? So that means you know the squares up to 15. Now, take a look at from 16 onwards, 16 square, 17 square, up to what, 20 square. So 20 square, everybody knows it's 400. And how about like 16 square, 17 square, 18 square, and 19 square? 16 square, 256. 17 is 289. How about 18 square? Anybody? You know the square of 18? Well, we have mentioned the square of 19 here. This is 19 square minus 1 is 360. So 19 square is 361. So we got the square of 19. Then what is 18? 18 is what? 324. So ultimately what happened here? So far we have reached the squares of numbers up to 20, right? And if you know the squares of numbers up to 40, this is perfectly all right. So once you reach up to 20, then you know what? Bridge the gap between 20 and 25. I'm pretty sure everybody knows the square of 25. 25 square is what? 625. So then go for 21 square, 22 square, 23 square, and 24 square. So we have the squares of that numbers here actually. 21 square minus 1 is 440. So what is 21 square? 21 square is 441. So well, 21 square, 441. Now we got the square of 21. How about 22? Well, 22 square minus 1 is 483. So 22 square is what? 484. Now 23 square is 529. 24 square is 576. So we have reached up to 24. Now, next one is 25 square, 625. Everybody knows that. So next step, what do you go from? 25 to 30, 30 to 35, 35 to 40. So if you know the squares of numbers up to 50, that is pretty good. So that's the best way to deal with the number series questions. Now we have another set of numbers here. So the first series in front of us is 123, 146, 171, 198, etc. Is there any peculiarity for these numbers at a glance? That's what exactly we are looking for. Is there any peculiarity for those numbers in the beginning itself before we get into what kind of patterns are connecting those numbers? Just take a look at. Well, we may find differences, we may think of squares. We have seen a couple of square patterns here, right? So we may think of that as well. Anyhow, I want you to think of 121 here. Why it is 121? 11 squares. So when I look at 123, the nearest square which comes to my mind is 121. At the same time, there is a cube as well, 125. So that is 5 cube. So this 5 cube and 11 square are near to this number 123. How about 146? 146, I know that 144, that is 12 square. This is 11 square, right? 121. This is 12 square. So that 12 square is near to 144. And is there any cube near to 146? Not really. Well, after 5 cube, the next cube what we have is 6 cube. 6 cube is 200 something. So there is no cube near to this number. So that means this cube pattern may not work for this question. Maybe the square pattern. So what we have here, 11 square, 121, 11 square plus 2. And this is 12 square, 144, 12 square plus 2. And this is what? 13 square, 169, 169 plus 2. And next one is 198. 14 square is 196. Probably you remember what we have discussed earlier, the squares of numbers. 14 square, 196. So this is 198, 14 square plus 2. So of course, obviously the answer, what we have is 11, 12, 13, 14. Next one must be 15. So 15 square plus 2, that's a pattern. 15 square plus 2. What is 15 square? I'm pretty sure everybody knows the squares of numbers, especially the numbers ending with 5. It's easy for you to remember the squares of numbers ending with 5. 5 square, 15 square, 25 square, 35 square, etc. So 15 square is what? 225. This is 225 plus 2. 227 is the answer. Well, always aware of one thing. When it comes to the competitive exam, we have the answer choices for each question as well. At least 4 answer choices. Usually it is 4 answer choices. Rare cases, you may have 5 answer choices as well. But this is just a practice section. That's the reason I don't have the answer choice for these questions. But when we get into the real questions, real practice, definitely we'll have answer choice for each question as well. By the way, we'll take a look at, what the squares of numbers ending with 5. So 5 square, 15 square, 25 square, 35 square, 45 square, up to what? 95 square. Well, is there any peculiarity for the squares, especially the numbers ending with 5? We'll take a look at that. 25 square is what? 25. 15 square is what? 225. And 25 square is what? 625. And 35 square, anybody? Anyone has any idea? 35 square. Well, if you're not sure about it, I'll just give you that answer as well. But there is a condition. If I give you the answer for 35 square, you need to tell me the answers for 45, for 55, 65, etc. Ready? So 35 square, 1225. Then what is 45 square? What is 55 square? What is 65 square, etc.? Now, let's analyze what exactly happening here. So, if there is a 5 square, there must be a 25 at the right hand side. For the answer. 5 square is 25. Here, look at that. 15 square, we have a 5. Of course, we have a 25. So, 5 square and 25. 25 square, we have a 5 square here. We have a 25 here as well. And 35, definitely we have a 5 square and we have a 25 here. And 45 square, if you have a 5 square, then you'll have a 25 in the answer. especially the end of the answer, right? And last part of the answer. Now, what is before that? So this case, it's 5. There is nothing before 5. So what you have, nothing before that 25 as well. It is not a decimal mark. Don't confuse. Okay, fine. Now, this is 15, right? So before that 5, you have 1. So that 1 became 2 here. So when it comes to the answer, 1 became 2. So what is happening here? 1 became 2. And how about this case? 2, it was a 2 here. Then when it comes to the answer, 2 became what? 6. So 2 became 6. See that? 2 became 6. And about this case, it's 3. 3 became what? 12. So 3 became 12. So what exactly happening here? 1 became 2, 2 became 6, and 3 became 12. So ultimately, you know what? 1 is multiplied by next number 2, and 2 is multiplied by the next number 3, and 3 is multiplied by the next number 4. So if that is the case, what is the answer for 45 square? That 5 square, 25 already there. Then 4 must be multiplied by next number after 4. Which is the next number after 4? 5. So 4 into 5, 20. So 20, 25 would be the answer. How about 55? Similar method. Well, 5 square is what? 25. Then what is it? Balance is 5, digit 5. That 5 must be multiplied by the next number. So the number immediate after 5 is 6. So 5 into 6 is 30. So 30, 25. Then 65 square. Well, we have 25 at the end. Then 6 must be multiplied by the next number. 7, 6 into 7, 42. And you can find, of course, you can find 75 square and 85 square and 95 square as well. And this is applicable only for 2-digit numbers. That means from 5 to 95. This method is applicable only for these numbers. Don't apply this for 105. You may not get the correct answer. So, in order to find the square of 105, totally different method. We'll get to that method later, not right now. So, these are the squares of numbers up to 95. 2-digit numbers ending with 5. Easy for you to deal with any such number falls into this category. Now look at that 7, 26, 63 and 124. When I look at 124, definitely, you know what, I think of 121 and of course I think of 125 as well. When I look at 63, I think of what, 64. 64 is what, 8 square and 4 cube. 4 cube is 64 as well. So this is 4 cube. This is 8 square. These two numbers are near to 63. And 124 is what? 124 is near to 125, it's 5 cube. And 121 is 11 square. About 26, you know what it is? Near to 25 is what? 5 square. And cube, nearest cube here is 3 cube. 3 cube is 27. So 27 is 3 cube. And 7. 7 near to what? 9. 9 is what? 3 square. And at the same time, it is near to 8 as well. 8 is what? 2 cube. So, do we have a pattern on squares or cubes for these numbers? 7, 26, 63. If you take squares, what kind of a pattern you get? If it is squares, well, it's 3 square minus 2. And 26 is 5 square plus 1. 25 is 5 square. And this is 8 square minus 1, 8 square minus 1. And this is 11 square, 121 plus 3. Do we have a pattern here? 3 square minus 2, 5 square plus 1, 8 square minus 1, 11 square plus 3. We don't have such a pattern here on squares. So that means we need to really think of something else. So squares won't give us the pattern. So probably completely ignore the square pattern. Alright, so the cubes pattern, what we have is, think about it, it's 2 cube is 8, so 7 is 2 cube minus 1, 26 is what, 3 cube minus 1, and 63 is 4 cube minus 1, 4 cube is 64, so 63, 4 cube minus 1, and 5 cube is 125, so the 124 is 5 cube minus 1. So it is 2 cube minus 1, 3 cube minus 1, 4 cube minus 1, 5 cube minus 1. So the answer is what? 6 cube minus 1. If you know the cube of 6, it is perfectly all right. But if you are not sure about what is 6 cube is what? 6 square into 6. 6 square is 36, 36 into 6. So 6 cube is what? 6 square into 6, that is 6 cube. So 36 into 6, mental calculation. So rounding method. So 36, take it as 30 plus 6. So 30 plus 6. There is no need to write it. This is for you to get an idea of our thinking method. That's the reason I just write it. In actual situation, when you do this kind of questions, no need to write. So 36, 30 plus 6 into 6, right? So 30 into 6 first, 180. 30 into 6, 180. 6 into 6, 36. 180 plus 36, what you get is 216. So pretty much 6 cube is 216 minus 1. So 215 is the answer for that question. The beginning, you may feel like it is a bit time consuming. However, once you get the hang of it, it's going to be pretty simple, because if you know the cubes, you get the answer. That's it. That's the way we proceed with these kind of questions. Now 1, 2, 6, 24 and 120. 1, 2, 6, well, 1 into 2 is 2, 2 into 3 is 6, 6 into 4 is 24, 24 into 5 is 120. So when you look at this, multiplication with the 2, multiplication with the 3, into 2, into 3, into 4, into 5. Next one is multiplication with the 6, 120 into 6. 12 into 6, 72. And we have a 0, so 720 is the answer. Simple. Now, next question, you know what? 1, 2, 6, and here we have 1, 2, 6 as well. So it must be, you know what? 1 into 2, 2 into 3, 6, 6 into 4. It's supposed to be 24, but it's given as 21. Previous question, it was given as what? 24, here it's 21. So 6 into 4 is not 21. So we cannot really proceed with the pattern into 2, into 3, into 4. So that's an issue we have on this question. Now, 21 into something, we have no idea. 6 into something is 21. Well, 21 is not a multiple of 6. So direct multiplication is not really possible. Then the possibility what we have is 6 into 3, 18. So 18 is pretty close to that 21. 6 into 4, 3 is 18, or 6 into 4 is 24. That's another possibility. So this case, you know what? 6 into 3 plus 3. 6 into 3 is 18. 18 plus 3 is 21. How about 21 and 88? 21 into 3, 63, right? 63 plus 3, 66. This is 88. Then probably 21 into 4. 21 into 4 is 84. 84 plus 4, 88. Perfectly all right. So into 4 plus 4, into 3 plus 3, and this one must be into 2 plus 2. 2 into 2, 4, 4 plus 2, 6. Yes. And this one must be what? Into 1 plus 1. 1 into 1 is 1, 1 plus 1 is 2. Done. So multiplication and addition. This is a combination of multiplication and addition. So into 1 plus 1, into 2 plus 2, into 3 plus 3, into 4 plus 4. Next one must be into 5 plus 5. 88 into 5 plus 5. So 88 into 5 plus 5, the best way to multiply is think of that 88, take it as 80 plus 8. So multiply this 80 with 5. 8 into 5 is 40, 80 into 5 is 400. So 5 into 80, 400. 5 into this 8 is 40. So 440 plus we have a 5. So answer is what? 445. Done. So that is a question which, you know what, multiplication and addition. It's a combination. And this is pure multiplication. And this is a cube-based question, and this is a square-based question. And earlier we have seen the questions which is summation, like the first number plus something is the second number plus something is the third number, etc. Now look at this question, 4, 9, 19, 39, 79, etc. 4 and 9, well, if you take difference, 4 plus 5 is 9. And 9 plus 10 is 19. 19 plus 20 is 39. 39 plus 40 is 79. Of course, see the differences? 5. 5 into 2 is 10, next difference is 10. 10 into 2, 20, next difference 20. 20 into 2, 40, next difference 40. 40 into 2, next difference is 80. So 79 plus 80 would be the answer. So 79 plus 80, make it like 80 plus 80, 160, but one less, 159. So the answer must be 159. That's one way of looking at that question. There is another way of looking at this question. Well, as long as you get the answer for this question, you know what, exam point of view, you don't need to look at the second possibility. However, this is for you to get an idea how to look at a question when you see that question for the first time. There are different ways of looking at it. 4 and 9. So 4 into 2 is what? 8. 8 plus 1 is 9. 9 plus 2 is what? 18. 9 plus 2 is 18. 19 is close to that. 19 plus 2 is 38. 39 is close to that. So 9 into 2, 18 plus 1 is 19. 19 into 2, 38 plus 1 is 39. 39 into 2, that is 78. 78 plus 1, 79. Then 79 into 2, 80 into 2, 160, then 79 into 2, 158. That 158 plus 1, 159. So the answer 159. So 79 plus 80, if you take it that way, you get the same answer. So this is pretty much, you know what, number series questions. These are kind of like we have discussed, simple and medium type of questions. Of course, there are questions which are much more challenging than this in every exam, especially the CUET. And definitely we'll take a look at those questions when we meet next time. So stay tuned. Thanks for watching.